So we already know how to do a regression on the calculator. So you're going to put data in the calculator. This is the temperature of soup that's cooling on the countertop. So we're going to remember how to enter data in a calculator and do a scatter plot. In a lot of your calculators, it's probably already in there from earlier today. It's under the stat key. So if you go stat edit, you should see maybe the list of data already in there. If not, you're going to enter the list of data. And we're going to view a scatter plot to see how this is an exponential curve. So it's under stat edit steps, but stat edit, you're going to have to turn on the stat plot. Someone probably already did that for you, but it's under the y equals key, or it's above the y equals key. Zoom 9, right? So if I go to second stat plot, that needs to be turned on. On my calculator, it's currently off. So if you hit enter twice, and then zoom 9, your curve should show up of just the data points. Looks like I have another graph in my y equals menu. So you see how that is not linear, right? Remember our parent functions? That is exponential. Okay. Stat calculate. Exponential regression is choice 0 in the list. So stat calculate choice 0. And we want to tell our calculator where to store the equation. So you might not remember how to store the regression equation. So I was going to write down those couple steps. So to store it, it's under vars, yvars, function y1. So before you hit enter, you want to store it in the y equals menu. So vars, yvars, function. See how it'll put y1 right there for you? So these are the four commands so that you can store it in y1. And then once you hit calculate, it'll make the equation for you. So who is successful on getting it to calculate that? Right? 176.19 times 0.96 raised to the x. See how the x should be in the exponent. So my goal for today was to just classify functions as exponential. So what makes them exponential is that when you're writing your equation out, the variable is in the exponent. So 0.962 raised to the x power. So your x is in the exponent. If you have something like x squared or x cubed, these are called power functions, right? Because x is in the base. 2 to the x or 3 to the x are called exponential functions because x is up in the exponent. So if x is not written in the exponent, you've got a problem because now you've got like a linear function or something. So you should be able to now take your equation, we all got the equation, and go through, and if that's in your y equals menu, you should be able to use your table to answer these questions. And if you forgot how to do average rate of change, can someone tell me the formula in case someone forgot how to calculate average rate of change? How do I calculate slope? Because average rate of change is the slope between 2 points. So it's y2 minus y1 over x2 minus x1 when you get down there, right? So you have two coordinates. At 2 minutes, they told me it was 165.8 in my table at the top. And at 4 minutes, it was 146.3. So you could do y2 minus y1 over x2 minus x1. And if you need help remembering instantaneous rate of change, call me over when you get to that question. All right? So you should have paused and tried C and D. And I'm going to put up the answers to C and D. So I used my table and I got 99 and then 24. So for average rate of change, I'm going to show you my answers, so you might want to pause and try it on your own. This I used directly from the table at the top. So if you used the table on your calculator, you might be slightly different, but you should still be a negative slope here, or a negative rate of change. And then I used this value from my table, but this value from the table at the top of the page. So again, if you used the table in your calculator for both, then you're going to have a slightly different answer here. And then instantaneous rate of change, you go to 1.99 and 2.01 in your table, and then I grabbed these y values, and then 1.99 minus 2.01 was that 0.02 number. So these were my instantaneous rates of change. So I also wanted to take a look